Okay, let's start now with this session of Take a Break by The Edge. This time we will talk about data mining applied to microservice performance. So who I am, my name is Fernando Contreras. I was born in Cuba and I graduated in the University of Havana of computer science. Then I've been working for several years in software engineering projects. I'm passionate about engineering projects, about performance, about research. I'm really motivated about knowledge sharing, and this is why I created my own blog, coded by myself, where I share tech articles that you can go to visit if you want. I work for DH Hospitality Solutions. Um, and actually, thanks to DH that give me the opportunity to present this meetup, it's about one of my other passions, which is the data science, the machine learning, deep learning, and so on. I've been looking for interesting topics to create discussions about it, and I found an interesting use case where we can actually apply data science to software engineering and microservice performances. And this is what we'll be talking about today. So first of all, what is DH? What do we do as a company? So DH Hospitality Solution is a company that provides connectivity to hotels through the rest of the world. So it is thanks to DH that hotels are visible in most of the popular point of sales that you may know. And we also provide a lot of tools that helps hoteliers to optimize their revenue and also provide booking engines, web studio to create modern websites so that hotels can sell reservations through in-house booking engines and so on. Today we will talk about detecting performance bottlenecks. And I want to present to you one paradigm that you can use to investigate and drive this research, which starts with the first step of performing detection. When you start actually investigating your performance issues, you focus on detecting what you need to fix at the first iteration of your research. And then once you understand what the weaknesses of your system are, you can build on top of this knowledge prevention mechanism like rate access limiting and so on. Once you have security installed on your system to prevent system failures, then you can focus on working on improvements. And once you have a new enhanced version of the system, then you can start again from zero and performing again detection in the new improved version so that you can spot what are the next steps that you need to optimize. So why is it important to do it? Well, sales and marketing needs to understand the system capabilities so that they can know which customers they can target and sell the product of the company. And then it is also important to position the company in front of the competition by selling real SLAs. So let's start by talking about the first step involving detection mechanism. I bring you a business case of company, a fast food company that sells products to customers. And I have for you a success story of a very famous company that you may all know, which is McDonald's, which based its success in their very first restaurant by selling SLAs. very competitive SLAs because actually they promised that they were able to prepare orders in only 60 seconds. So how do we set up SLAs? In this fast food use case, you have stock and you have to prepare orders. And then every order has a preparation delay, depending of the nature and the volume of the order, of course. And this preparation delay is actually the variable that you need to understand and to optimize so that you can set SLAs on that. So how do you measure your system capabilities? Well, it has to start by collecting data. If we put all the data regarding orders in a row, so I mean all the data describing the nature of an order, which is the counts of the products that are contained in the orders. You put all this in the row and then you start collecting information about the duration of the preparation of every order. This duration might become predictable from the features that you collected before. And this is what we'll be talking about today, because all the research are based on the assumption that we can predict from features performance metrics, which are based in the duration of execution. So let's go back to hospitality industry and see how it can apply to the hotel business. Yeah, imagine we have a hotel, we own a hotel, and then at the other side of the world, you have millions of customers that are trying to search to book hotel rooms from 100 different web portals, like might be hotels.com, booking.com, Expedia, that you may know, and also the Edge, because the Edge also provide its own different booking engines so that hotels can have in-house reservations and optimize their revenue. Then imagine you as a revenue manager of your hotel, you want to update the calendar of prices, and we, as the Edge, we have to propagate this information to the rest of the world instantly so that the active users that are on the web searching for reservations can have the up-to-date prices that we just update in the system. At the other hand, imagine that one customer from one platform book a room, and what happens if this room was the latest available for a given date? We have to propagate this information back to all the providers that we have so that they are aware of the change in the availability for this hotel, and then avoid a very undesirable effect that is called overbooking. So let's see, how do we set up SLAs? We have our customers, which are the hoteliers, and then they must be able to update their inventory of prices, restrictions, and so on. Then our mission will be to update and propagate these changes through the rest of the partners in the whole world so that they have their information up to date. And the propagation delay is the variable that we need to understand in our system so that we can optimize it and sell fair SLAs. So let's see what is an inventory update. It's just a XML message containing information about the hotels, the rooms, the different prices that we want to sell, the dates, and the specific prices and restrictions, and might be also availability. It might be also restrictions about the date for the check-in and check-out, and so on. So how can we exploit this data? So first first I start talking about analytics, I had to mention OpenTelemetry, which is actually the technology on which all the research are built on top of that. So what is OpenTelemetry is a very common protocol that helps applications to implement observability. Observability is the ability to have a deep insights in all the application activities so that you can have further information and details from what you can have only by having logs and metrics. It is based on top of the code instrumentation in a way that if you instrument the code of your application, you can have exported all the traces that you need about all kinds of operations like SQL or NoSQL operations, HTTP call. You can also create custom activities if you want to instrument and analyze any specific part of your code or your application. And then a very interesting feature is that it provides a correlation between the traces of all the applications of your system. So let's see how it looks like. This is an example of visualization. You know, as you see here, all the traces are correlated and you have information about timestamps, duration, and so on. You can have further information like tags, like information that helps you filtering and searching and so on. Then you have an example here of a trace of different traces from different applications that are correlated thanks to the fact that OpenTelemetry is built on top of the assumption that all the traces are carrying a common correlation ID that helps afterward to put all the traces together in the same screen. Imagine that you have a customer that is exploring your website and it is updating or submitting a form. Then it will trigger a series of operations in the system through different services. And then you can correlate all this activity with all the details to a business activity that might be a reservation, a cancellation, and so on. So let's see, how do we collect data from these traces? Imagine that you start collecting information about all the inventory updates, which can be the number of rooms present in the updates, the number of rates, the number of periods, the calendar days, and then you can also store the hotel IDs, for example. Then you start collecting from the metrics or from the OpenTelemetry traces the performance metrics, which are the total duration in seconds that the whole system took to process every single message. And you can have the same also divided by every single involved service in the system. So what do we what can we get from this data in a first sight? We can already know in what application it is happening the most of the computation time. I provide you with an example of an application which is consuming the 85% of the processing time of the whole system. You can also have these metrics divided by application. So within all the activities involved in a single application, you can know where your computing time is happening. And in these examples, you can see that the same application that you saw before is highly impacted by a single operation, which is taking 84% of the processing time, which is a store procedure. We can also have information about the computation, the data access graph. What you see at your left, the nodes that you see is the different services of the system. At right, you see the different store procedures. And it is very interesting because here you can see how the same store procedures are being accessed by different services. And then it might suggest that there are commonly accessed data that can be put maybe in an optimized data storage so that we can optimize the read speed of the data on the system, or maybe put this data to transit between one service and the other through the transport messages, or a lot of suggestions might rise by looking at this data access graph. So how can we determine the nature of the data or the nature of the business activity that impacts the most the system? Today, I will present to you two different diagnostic methods. The first one being the correlation coefficients, and the second one, the feature importance coefficients. So let's start by the first. The first is the correlation coefficients. So what is the correlation coefficient? It is a measure that describes how correlated are two different variables. In other words, it means how the behavior of one variable impacts the behavior of the other one. For example, here at your left, you can see how these variables present a high negative correlation, because the value of X increases, the most the value of Y decreases. So this is an example of high negative correlation. At your left, you have, on the contrary, a perfect positive correlation, because the most X increases, the most Y decreases. At the middle, you have an example of two variables that are not correlated at all, because they are completely independent. Then I provide you an example of correlation so that you can have an idea of with a real use case, which is a high correlation between the square meters and the house prices. For instance, in Richmond, in United States. And now you can see how the most, which is logically, most you have square meters in your home, most its value will increment. And as you can see, there is a kind of noise, because it is not the only variable that impacts the prices. Here you can see an example of the correlation between the business metrics of an inventory updates, which are the number of rooms, number of rates, number of periods, and calendar dates. And you can see how there is a trending, an increasing trending, which means that the most you have entities in the updates, the most the system will spend computing time, which is completely logic. Then let's try to analyze the business impacts of the impact of performance of every business variable. So by taking a look at the correlation metrics, we see how the number of periods seems to be the variable that impacts the most the global performance, which has the highest correlation in the global statistics. Then we can have the same measures, but divided by application. And you can note how these two applications at the left bottom corner seems to be very impacted by the number of rooms present in the updates. Just for a reminder, the number of rooms describes how many XML tags we have in every planning update, as you see here. So this last phenomena can be explained by the fact that at some point, one of the application is performing a split of the traffic and doing processing of some submessages and creating one submessage by different room. And this is why you see this split here that is actually multiplying the computation graph. And then the last two applications that you see are highly sensible to the number of rooms, because more you have rooms, more they will be solicited to execute a processing. And this might suggest that this is a pattern that needs to be optimized. We can also have the correlation between the business metrics and every single operation or activity on your application. In this case, I show you the different store procedure and their correlation with the business metrics. And as you see here, the highest correlation is between the number of rates and the store procedure call that is named get rate key, which might maybe suggest that this store procedure is called once by the different rates that you have in your date, instead of doing some batch reading from the SQL database. And that is something that maybe needs to be optimized. So you see how these simple metrics already provide insights of what needs to be optimized. So I show you some code that helps to compute the correlation matrix that you need in order to have these insights. I will not go deep into the details of the code because it's quite straightforward, and it's just to illustrate how simple it is with a couple of Python lines to compute these metrics. Yes, correlation is good, but it's not enough, because sometimes it might be an outlier. I provide you an example of a correlation from a very popular website, which says that there is a high correlation between engineering doctorates graduates in the United States and the mozzarella cheese consumption, which are variables completely decorrelated. However, they present by accident a correlation. So this is why we will talk about feature importance coefficients, which is a machine learning mechanism to determine how important is every feature to predict a target variable. And our target variable, of course, here is the performance. If we compute the correlation, the feature important coefficient for every business metrics to predict the final performance, we might have more accurate insights of what variable is actually impacting the most the global performance. So how do we do that? If we go back to the business metrics that we had collected in the form of CSV, and then we put together in a row all the performance metrics collected from the traces, then these performance metrics might become predictable. If you train a machine learning model to do regression of these variables from the features that you have at your left, then the coefficients learned by this machine learning model will be actually the feature importance coefficients that we are looking for. So let's talk about feature engineering, because we cannot include everything as it is in this computation, because we might find the case that we want to analyze, for example, hotel IDs or client IDs, customer IDs, or whatever. But these, even if they are integers, they are categorical data. And machine learning works on numerical data only. Fortunately, there are several encoding mechanisms that allows to transform categorical data into numerical matrices of zeros and one, allowing us to include categorical data inside this computation. This one is the what hot encoding, which is simply putting one whenever it is the column representing the category and 0 everywhere else. So how can we detect if a single customer is impacting the performance of the platform more than the others? Well, if we include the customer IDs into the feature importance computation, we might find ourselves in the case of having one customer which is impacting performance more than the rest. Or it is maybe a set of customers having some common behavior in the platform. And this might be explained, for example, by the usage of feature toggles that condition the behavior of the system for a set of customers. We tested this by using a feature toggle that enables or disables a cache that has been built for optimizing performance. Then if we disable this cache for this given customer and we play and we generate data and generate traffic on the platform and then collect all the traces and perform the computation, we will find that this customer is having more impacts on performance than the rest. Or maybe a given customer presents some data anomaly that needs to be studied and optimized. There are a lot of open questions that this might raise, but it is very interesting because it actually spots the performance problems against target customers. So in the same way, I show you the lines of codes that you need to have this. It is very simple. You split your data and you build the pipeline using a standard scaler because all the features that you find are not in the same scale. So you need to scale so that it optimizes the learning process of the machine learning model. I'm using a rich regression model, which is a very simple model for performing regression. And then after training this model, I'm just analyzing the coefficients which give you the values that we are looking for. So what else can we include in this computation? We talked about business metrics. We talked about user IDs. Also, what else? As you can imagine, the nature of data is not the only fact impacting performance. So you might also include in this computation all that is related, all the information related to the system state, because sometimes we work on systems which are stateful, and then some information about the state might also be important for predicting performance. It might also depend on the traffic load. It might also present some seasonality. And there are interesting use cases that prove that seasonality is important when predicting performance of a system. For example, before the end of the year, you can find that there is a high traffic on hotel reservations because people are moving around and so on. And a very interesting use case is also in a platform of coding, which is called Advent of Code. I don't know if you know, but it is a platform that every year, like the Advent calendar, provides coding challenges to developers. And then every day at midnight, one new challenge is opened. So the platform goes from 0 traffic to 100 millions of users trying to get the exercise and be the first resolving it. So there might be other factors impacting performance than just the metrics that we analyze. So it is very interesting also to include software versions, because we developers used to improve applications and then always delivering new versions which are incremental, and then one new version might port performance improvements of performance regressions. Then you might also spot that one specific version of the software that you deploy is having more impact on performance, negative or positive impact than the others. And this is very interesting metric to include in the feature importance computation. So let's talk about preventing. How do we prevent the system from failures? Well, once we are capable of predicting performance or total duration for every message that we process, then we can assign a score to every message and build on top of these insights rate access limit mechanism based on these scores, and not only in the classical rate access limited, which are only based on the number of requests, because you might have 2,000 requests, very little that are processed instantly, and only 20 very heavy, which are impacting the system. So it is a good idea to build a quota based on these metrics and all the insights that you can have from the previous analysis. So improving, how does this analysis can help us improving the system? Well, as I mentioned before, we can include software versions in this analysis so that we can test and launch all the analytics before and after the improvements, and you can have this kind of benchmarking that states and reflects how a software update would impact positively or negatively performance. This is an example of the performance applied to stored procedures, SQL stored procedures, from one software version to another. So for this research, I have to mention what I used. It was based on Jupyter notebooks and Python. I was using pandas for all the data manipulation and sklearn, which are both very popular frameworks for doing data science and open source. And then for all visualization, pie charts, graph, and so on, I used Seaborn and Matplotlib. So for the code instrumentation, in order to be able to trace with OpenTelemetry, we use at the company C# and F# applications, and then just installing the right nuggets, which are also open source. You can have this behavior and export your traces to the right backend so that you can afterwards collect all the information that you need. Okay, that's all I had to say. So it's the time for questions, if you have any.
Yeah, in this regard, you can either ask those in the chat if you're not comfortable asking them directly with your voice. You can ask them in French or in English. I'll translate them to English. Or if you actually want to open your mic, go ahead. It's the right time for that.
I'm okay also for a Spanish question. I can translate.
And if we have no questions, actually, in the next 1 or 2 minutes, I believe it will be time to take a break.
That's it.
Hello, good afternoon.
Hello.
Thank you, Fernando, for the presentation. and thank you for the invitation. Actually, I have a question about web service used by for the hospitality. Could you please give us an example?
Of the web services?
Yeah.
If I understood well, you want to know what kind of web services we use in the...
Yes, and used for to collect the data.
Yeah, so yeah, our entry points to the system are mostly APIs, so that our partners can call and send in one hand updates for performing inventory updates, which are HTTP web applications.
Okay.
Mostly we have ASP.NET applications built on top of XML contracts because the hospitality industry is based on XML.
Okay.
And then this is our entry point that we instrument with the proper NuGets that exist for instrumenting ASP.NET applications.
Okay.
And then the rest is communication through message queues. We have data services, we have Redis, we have different kind of service. We have NoSQL databases that can be also instrumented. And yeah, that's it.
Okay, thank you.
Does it answer the question?
Yeah, it's yeah. I get the answer. Thank you.
Welcome.
We also have another question, which is a question regarding the backend that we use to store the OpenTelemetry data.
Yeah, today it is in proof of concept, and we are using Tempo to store the traces. But then we are also working on installing, the agents so that we can distribute the traces to different backends. For example, Tempo for visualization, and then we plan to put in place some in-house analytics. So we will probably build our API to receive the traces and produce real-time statistics so that business people or developers can observe the behavior of the system, having a statistic for the latest day and so on. And then maybe why not tomorrow have the possibility to export traces to some vendor like Datadog and so on.
We also have a remark saying that we could actually try F# notebooks instead of Python. So it's just another way to extract information.
Yeah. It is just that the data science tools that I know are based on Python, so it was easier for me. But yeah, I am aware that we can use F# and also C# from Jupyter Notebooks.
Yeah, I believe what's really important in what you presented was the fact that we actually basically did what you explained, which is collect, basically compute, and then actually act on it. And I believe it's the tools also that you presented were what worked for us, but you can adapt it if you really want to.
Yeah.
Do we have any other questions? Because I think for now it's all of it. Okay, we have another question. Do we use data mining in production? And if yes, what is the architecture used to have real-time analytics?
Yeah, so far, as I mentioned, it is in proof of concept. And actually, all the statistics that I collected were artificially generated by batches of. We have built tools that helps us building batches of thousands of messages and then call the system with that, so generate artificial traffic. But it is the objective is that we put this in production, but we are going step by step.
Yeah, we are actually trying to go to production, basically depending on every product's maturity, because we have several products in the edge, and this in particular was a very wide project, encompassing as many projects as we could, and yeah, it's going live basically app by app, because we had to make do with the different timelines of every app.
Yeah, it is also related to the latest question about when I mentioned that we are studying the installation of the agents to collect the traces, so that we can configure agents to send traces to different backends, and then we plan to have our own in-house analytics service that will receive the traces and update the statistics that we can display in an internal tool or auto-generated, I don't know, might be auto-generated websites having the traces and the statistics collected from the latest dates and so on.
Yeah, for quick insights, we actually use Grafana, but we are actually thinking about expanding on that and trying to have basically self-tailored applications dedicated to what actually each product wants to have.
Yeah, because actually it is also slightly different to do these analytics in you know, artificially generated traffic or the production, because actually when you generate traffic by yourself, you are thinking about the worst case, and this is how engineers think about. We are learned to do to think always about the worst case, and also then we are generating very huge traffic, but it doesn't reflect the reality of production traffic. Then you have to perform the same research in production, because maybe the nature of data is not the same, and maybe you would not prioritize the improvements that you found in your artificial data, because it doesn't impacts production the same way it impacts your staging environment, for example.
Hello, Fernando. Can you guys hear me
Hello.
okay? Yeah,
Yeah.
so I got a quick question. So if you plan to deploy this tool, are you going to use what type of pipeline, or what kind of tools are you planning to use for deployment on your production environment?
Do you mean the code instrumentation, or the tool that will collect the traces and perform analytics?
Yeah, the tool to collect traces and perform analytics.
Yeah, it is still a working process. There are plenty of possibilities. What one of them might be to have web APIs that will receive the traces and just put the results, the aggregated results, in a data storage that might be a blob or a NoSQL database, relational database. It might vary on the way of how you want to handle your data. But yeah, one possibility might be just HTTP APIs that will receive the traces and then maybe do some formatting, arranging, and so on, keeping only the data that you need, and then one service behind which is computing the traces all the time.
How do you plan to process all that data?
To process?
Yes.
Actually, you can do what we call batch computation. For example, you just store your data in an optimized data storage so that you can read it afterwards and process your changes. What the research that I did was based on CSV files. So you can imagine having this stored in a table and then having a process that is ingesting this data and then performing all this analysis in async mode, so in batches, and then outputting all these results to somewhere where we can visualize and and perform analytics in real time?
Basically, it's just the normal processing of a cube in business intelligence setups. It's either that, or you can just compute them on the fly if you actually can aggregate information right when you receive them.
Yeah.
For now, we were actually trying to improve performances of a system overall, especially against a very special use case against which we tested, and hence why we had all this information in staging, and why we actually prepared the setups. As a next step is actually to use them, and I believe it's part of a growing concern of using actual metrics in production. I'm not sure we actually already decided on how to do that, but what's important is we have the several ways to do it. So yeah, basically batch processing, live processing, and after that we will use what's most important for us, what's the most fit for our needs.
Yeah, it's a very good question, because it might suggest two different approaches. One of them is doing these computations on demand, which means that when you go to a web page, you are a service behind which is generating on real time the data for the period that you ask it, like Grafana does, and Elasticsearch and so on. And one other approach is to pre-compute this information and make it available somewhere so that you can go afterwards and see the different reports. There are two possibilities. We haven't decided yet which one to take, but I think both are advantages and disadvantages.
Sounds good. Thank you.
Welcome.
Thank you for the question. Any other question? As far as I can see, there are no other questions.
I guess
So,
it's the time to say thank you for participating. It was exciting to share this with you, and see you the next time.
Thank you, Fernando.
Thank you.
Thank you.
Thanks.
Thank you, Fernando. Felicitations.
Merci.